to section 7.2 on derivatives of the sine and cosine functions. We'll do this over 2 days. So a quick reminder of what a derivative is, different ways to define it or think of it, but a very useful way to think of the derivative, probably the most common way to think of it, it's the slope of the tangent line to the graph f. So what we're going to start with is two graphs of two functions. The first one is going to be f of x equals sine x, and the second one's going to be f of x equals cosine x. Now, hopefully by now you're getting absolutely sick of me graphing these two things because we've done this many times over the last couple days. So, super quick, sine graph starts at 0, at pi over 2 it's up to 1, at pi it's down to 0 again, at negative pi over 2 it's at negative 1, and at negative pi it's up to 0. So, there we go. For the cosine graph, it starts at 1, at pi over 2 it's at 0, and at pi it's down at negative 1. At negative pi over 2 it's at 0, and at negative pi it's at negative 1. So it looks something like that. Now what we're interested in is the derivative of both of these. So let's start with the sine graph. If we were finding the derivative of this, we'd be interested in the tangents, the slope of the tangents at all the different points of this graph. Now obviously we can't do every single point, we'd be here all day, but there's a couple points we could do very, very easily. Like this point, I haven't drawn it very well, but what's the slope of the tangent there? If you were to draw the tangent, it would go like this. It's a minimum. It would be a horizontal line, which means the slope is 0. At negative pi over 2, the derivative, so what I'm graphing here is f prime of x, the derivative is 0. Where else do you see spots like that? Well, how about up here at this maximum? This point would have a derivative also of 0. It's a tangent line is horizontal. That means the slope of the tangent line is 0, so we're going to put a 0 right here as well. Now, in between those 2 points, what would you say about all of the slopes? The tangent lines all have positive slope. And right here, you can see the slope is pretty much how much? 1. It's pretty well going from corner to corner here. It's a 1. It's hard to tell exactly, but I will assure you this is true. The slope at that point right there, when x equals 0, is 1. So right up here. Now let's look at the slopes over here. These are all negative slopes. And somewhere, turns out it's right around here, you have a slope of negative 1. So at negative pi, the slope is negative 1. It actually ends up, you get the same thing over here. Negative slopes all over here, and you end up with a negative slope of 1 also at pi. So this is also negative 1. So I'm not asking you to, be able to tell it was exactly negative 1. I am kind of basically telling you that, but I hope you can at least see these are all negative, so it should be down here. This is where it's 0. They're all positive up here. And what you can see you end up with is something that looks like this. Now, what do you think of when you see that? This graph is exactly the same as this graph. In other words, the derivative of sine x is cosine x. When you take the derivative of sine x, you get cosine x. Now, I know what you're thinking. You're thinking, well, I know what this is going to be. This is going to be sine x. Not so fast. We have to do the same sort of thing. So where is it on this graph that we get tangent lines with slope of 0? Right here, and right here. So we can put those points in right now. That means at negative pi, the slope of the tangent line is 0. At 0, the slope of the tangent line is 0. And at pi, the slope of the tangent line is 0. Where do you think it equals positive 1? It equals positive 1 right here at negative pi over 2. So I'll put a point right here at 1. And where does it look like it might equal negative 1? That is right here at pi over 2. So we have a point right here. If we draw a curve between those points, what does it look like this time? It doesn't exactly look like the sine graph, but it looks similar. Do you see the only thing different between this graph here, excuse all the blue stuff, and this graph here? It's just reflected over the x-axis. So it's not actually a sine graph, it's a negative sine graph. The derivative of cosine x is negative sine x. So these are two very, very important derivatives to know. I will give them to you on quiz and tests, but you should just get to know them. You're going to use them so much. Okay, so we're going to differentiate some things here. Now, you're going to use the chain rule a lot when you're using trigonometric functions. So we want to find y prime. And what we're going to do is chain rule here. What the outer function here is sine of something. Okay, so the first thing we have to do is figure out what's the derivative when you take sine of something. When you take sine of something, you get cos of something. So we're going to get cos something. How much is the something? 3x. And then, since it's chain rule, we now need to multiply by the derivative of the inside. What's the inside function? The inside function is 3x. What's the derivative of 3x? 3. So you end up with cosine 3x times 3, but a better way to write that would be to bring the 3 out front. You get 3 times cosine 3x. If it helps you understand, you can put the 3x in brackets to show that's the argument of cosine here. Same sort of thing in this one. We have an outer function, which is sine of something, and we have an inner function, which is x cubed. So we start by taking the derivative of sine of something. Well, sine of something, we just said, is equal to cos of something when you take the derivative. So we'd have cos of that something, which is x cubed. And then we multiply by the derivative of the inner function. What's the derivative of x cubed? It's 3x squared. And just like before, we want to bring that 3x squared out front. We get 3x squared cosine x cubed. Okay, the last one's a little bit different. There's an outer and an inner function again. What's the outer function this time? The outer function, remember, this is the same as sine x all cubed. So the outer function is actually something cubed. The inner function is sine x. So we have to start with this outer function, chain rule here. How are we going to do that? We're going to bring the 3 down. We're going to keep that inner part the same, the sine x, but it's now going to be raised all to the second power. And then we're going to multiply by the derivative of the inner function. Well, the inner function is sine x. What's the derivative of sine x? Cosine x. So this would be your answer. Now, in order to simplify this one, what I would do is change this squared here. We don't usually write it like that. How do we write that? We write that as 3 sine squared x. That's what sine squared x means, the same as sine x all squared times cosine x. This would be a great answer. Okay, same sort of thing on this one. You might want to rewrite this. We have sine x squared minus 1 all cubed. So you have to start with the outer function. The outer function is something cubed. So we're going to bring that 3 down. Y prime equals 3. Then we have our sine x squared minus 1, but it will now be squared. Now we move inside. Hey, we have to use chain rule again. Again, we have an outer and inner function. The outer function is sine of something. The inner function is x squared minus 1. So let's start with sine of something. The derivative of sine of something is cos of something. So cos of exactly the same thing inside. And now we have to multiply by the derivative of the inner function. The inner function this time is x squared minus 1, and the derivative of that is 2x. Alright, let's clean this up. So we've got 3 times 2x, so we get 6x. Then we have this sine blah 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 squared. Remember, that's the same as sine squared x squared minus 1. And finally we have the cosine x squared minus 1. We're done. Okay, this one, the outer function is what? It's not something squared. Otherwise the 2 would be right here if it was something squared. The outer function is cosine of something. So the first thing we have to do is take the derivative of cosine of something. Well, we said the derivative of cosine is negative sine. So we're going to get negative sine of all this. This all stays the same, 2x cubed minus 1 squared. Then we're going to move into here. Now, again, we're going to use chain rule. We have something squared. So we have to do that squared part first. We're going to bring the 2 down. So remember, we're multiplying. 2 comes down, still have the 2x cubed minus 1, and that 2 drops down to a 1, which you don't even have to put. Now we take the derivative of the inner function. So the derivative of 2x cubed minus 1 is 6x squared. Okay, to simplify that, let's bring the 2 and the 6x squared and the negative here, bring those all out front. So we have 2 times 6 is 12, negative 12 x squared. And we also have this 2x cubed minus 1. I'm going to write that next, 2x cubed minus 1. Then I'll finish up with the sine 2x cubed minus 1 squared. Okay, they're getting a little bit more difficult now. This is sine squared cosine x. I know that looks totally bizarre. Do you understand what this means? This means that your argument is cosine x. So another way you could write this is y equals sine cosine x all squared. So the outer function is the squared. You're going to have to start with that 2 there. So in order to do that, we'll bring the 2 down, rewrite the inner part, the sine cos x, and now it's going to be to the 1, but we don't have to bother to put that. Okay, now we're looking at this bit here. Our outer function this time is sine. So when you take the derivative of sine, you get cos. And then we just rewrite here, cos of cos x. The argument here is cos x. I know that's weird. Whoops, cos x. Then we look at the inner function and we take the derivative of that. What's the derivative of cos x? Negative, so we're multiplying by negative sine x. Okay, I'm moving that all over. So we have a negative and a 2. So we get y prime equals negative 2. Now the rest of this you could write in almost any order. I'm just going to write it the order I have it here. Sine of cosine x. I know that's the weirdest part because your argument of this is cosine x. Right? Then we have cosine, and the argument of this one is cosine x. And finally we have our sine x. Okay, implicit differentiation. Remember what that means? It means we can't get these y's by themselves. So we're going to take the derivative right now, but every time we take the derivative of y, we're going to put y prime, or dy over dx if you prefer. So let's start. Here we have x and cos y. We're going to have to use, I'll write it in here, you're going to have to use the product rule here. So remember the product rule is f prime g plus f g prime. So our f prime, that'd be the derivative of x, well, that's just 1. Then we multiply that by our g, which is cosine y, plus our f, which is x, times the derivative of g. The derivative of cosine y is negative sine y. Wait, then we also have to take the derivative of the inner function here, this y. What's the derivative of y? It's 1, and since it's y, we have to say 1 y prime equals on the other side. Okay, first of all we take the outer function, which is sine, and we take the derivative of that. The derivative of sine is cosine. So cosine, and just keep the inside the same. Multiplied by, now we have to multiply by the derivative of the inside. What's the derivative of x? 1. What's the derivative of y? It's also 1, but because it's a y, we have to put 1 y prime. Okay, simplifying, let's just write this as cosine y. We have a minus here, so take away x sine y y prime equals, now I think we should expand here. We're going to multiply cosine x plus y times 1 and cosine x plus y times y prime. So if you do that, you're going to get cosine x plus y when you multiply by 1 plus cosine x plus y y prime. Now, our strategy is to get the y primes on one side. Why don't we move this y prime right here, move that to the other side, because that negative will become a positive. That's nice. So we'll leave this cosine y here. Let's bring this term here. There's no y prime, so let's bring that over here. So minus cosine x plus y equals, we'll write this one first, although it doesn't matter at all, x plus y y prime, and we're bringing this over, so we get plus x sine y y prime. Now, you can't factor out a cosine. That doesn't make any sense. You can't do that. So there's actually nothing we can do on this side. We're just going to rewrite cosine y minus cosine x plus y. On this side, you can factor out. What can you factor out? The y prime. That's perfect. That's what we want to do. So we have to take out the y prime, and we're left with cosine x plus y plus x sine y. Last step. We can divide both sides by all this big square bracket here. So that'll cancel out on this side, and it'll just put this over that denominator right there. So basically we're left with y prime equals all this cosine y minus cosine x plus y, all divided by this cosine x plus y plus x sine y. And that is the derivative. Pretty complicated stuff. Last question. Find the equation of the tangent line to y equals sine x divided by cos 2x at the point where x equals pi over 6. Okay, in order to get the equation of a line, you need two things. You need a point and you need a slope. Okay, how are we going to get the point? Well, it tells us it's a point where x equals pi over 6, but we also need a y value. How are we going to do that? By plugging pi over 6 into this. So, in order to get our y value, we're going to do sine of pi over 6 divided by cosine of 2 times pi over 6. So, sine of pi over 6. Well, pi over 6 is 30 degrees. You know what sine 30 is? It's very nice. It's 1/2. And on the bottom, we get cosine of 2 times pi over 6 is actually pi over 3. Because this 2 and this 6 cancel, and you're left with a 3 there. And happy day, do you know what cosine of pi over 3 is? That's 60 degrees, and cos 60 is 1/2. Hey, 1/2 divided by 1/2 is 1. So our point is pi over 6, comma, 1. That's the point we'll be using. Now we have to get the slope. How do you get the slope? You know how to get the slope. To get the slope of a tangent line, you find the derivative. So we got to find y prime. Which rule are we using this time? Quotient rule. So remember, the quotient rule is f prime g minus f g prime all over g squared. So f prime, this is our f up here. The derivative of sine x is cosine x. And then we rewrite the bottom, cosine 2x minus the first one, the sine x, times the derivative of the bottom. Okay, to take the derivative of the bottom, the outer function is cosine, and to get the derivative of cosine, it's negative sine of the whole thing, the 2x, and we have to multiply that by the derivative of the inner function, which is 2x, so we're multiplying it by 2. This is all divided by the bottom, cosine 2x, all squared. So let's simplify. There's nothing you can do here. Cosine x, cosine 2x. Okay, we have a negative, negative, and 2. So that's actually positive 2. So we have plus sine x, sine 2x. Don't do sine squared here. They have to have the same argument in order to do that. Here we have sine x, here we have sine 2x, so there's nothing we can do. This is all divided by, you can keep it like this if you want, or the way we are supposed to write that is cosine squared of 2x. So this is the derivative right here. How are we going to get the slope at this specific point? We're going to plug the x value of pi over 6 into all these x's here. So I'm going to say at pi over 6, y prime equals cosine of pi over 6, cosine of, are we okay with us knowing that 2 times pi over 6 is pi over 3? I'm trying to save a little bit of time here. Plus 2 sine of pi over 6, and then sine of 2 times pi over 6 is pi over 3. All divided by cosine squared of 2x, so 2 times this again is pi over 3. Cosine of pi over 6, well that's 30 degrees, and cosine of 30 degrees is root 3 over 2. And then this is 60 degrees, and cosine of 60 is 1/2. Plus 2 times sine of pi over 6, that's 30 degrees, so that's 1/2. And sine of, this is 60 degrees, that's root 3 over 2. All divided by, okay, cosine of pi over 3, that's cosine of 60, which is 1/2. And of course, we're squaring it. So if we multiply the first two fractions, you get root 3 over 4 plus, well those cancel, that just becomes 1, so root 3 over 2 all over 1/2 squared is 1/4. Let's get common denominators here. So it should be 4, so you're going to change this to a 4, and you have to multiply this by 2 as well, so you get 2 root 3. So you end up with 1 root 3 plus 2 root 3 is 3 root 3 over 4 divided by, but I'm going to multiply by the reciprocal, which is 4 over 1, and these cancel out. So we're left with a slope of 3 root 3. So we have our slope right here, we've got our point right here, and what we're going to do is we're going to put it into point slope form. So remember, point slope form is y minus y1 equals m times x minus x1. So we'll have y minus the y value, well our y value is 1, equals the slope, we just found the slope, it's 3 root 3, and then x minus the x value, which is pi over 6, right there, pi over 6. And we like it in general form in this course, so I'm going to expand over here, and when I expand I get 3 root 3x minus, okay, this 3 and this 6 are going to cancel, you're going to be left with a 2 down there. So you're going to get root 3 pi over 2. And then I'm going to bring that 1 over and add it, so I have plus 1. Now remember, in general form we can have no fractions. So in order to get rid of this 2, we have to multiply everything by 2. 2y equals, multiply this by 2, 6 root 3x minus, multiply this by 2 and it just cancels, root 3 pi plus 2. Going to multiply that by 2 as well. And finally we want our x to be positive. It is. We want everything on the same side, so we've got to bring this over. So I'm going to have 6 root 3x minus 2y minus root 3 pi plus 2 equals 0, or I'll put on this side, equals 0. And this is the equation of the tangent line, and that is a pretty complicated question. Okay, hope you get it. That's 2 days down.